August 15, 1944. Kokura Arsenal, Japan. Colonel Chikao Yamada stood in the sweltering heat of the weapons testing facility, watching with growing alarm as the latest prototype of Japan's Type 4 rifle jammed for the fifth time in 10 minutes. The bolt mechanism, supposedly based on the captured American M1 Garand, had seized completely in the humid conditions that simulated jungle warfare. Yamada's engineering team had spent 18 months reverse engineering what they believed was America's secret to rapid-fire infantry superiority. What they had created instead was a weapon that would fail Japanese soldiers at the moment they needed it most. The irony was devastating. Japan had captured the M1 Garand's design secrets, understood its mechanical principles, and possessed some of the world's finest metallurgists. Yet their copy would prove catastrophically inferior to both the American original and Japan's own bolt-action Type 99. In their desperate attempt to match American firepower, Japanese engineers had created a weapon that epitomized the empire's fundamental misunderstanding of industrial warfare. The story of the Type 4 rifle began with a moment of revelation that should have changed everything. On December 8, 1941, during the assault on Wake Island, Imperial Japanese Navy forces captured several M1 Garand rifles from defending U.S. Marines. Lieutenant Commander Kenji Hatanaka, examining the semi-automatic weapons in the aftermath of battle, immediately recognized their significance. These rifles could fire 8 rounds as fast as a soldier could pull the trigger, requiring only a simple thumb movement to reload. Japanese infantry, still equipped with bolt-action rifles requiring manual operation between each shot, were facing an enemy with a 3-to-1 rate of fire advantage. Hatanaka's report to Tokyo was urgent and prophetic. The Americans have achieved what we thought impossible: reliable semi-automatic fire in a standard infantry rifle. Every American soldier is equivalent to 3 Japanese soldiers in sustained combat. We must copy this weapon immediately or face inevitable defeat. The captured M1 Garands reached the Kokura Arsenal in January 1942, where Japan's most experienced weapons designers began the painstaking process of reverse engineering. Led by Colonel Kijiro Nambu, the team that had created the Type 99 light machine gun, the project seemed destined for success. The M1 Garand's operating system was elegantly simple. Gas pressure from fired cartridges operated a piston that cycled the bolt, ejecting spent cases and loading fresh rounds. American engineers had solved the fundamental challenge of semi-automatic rifles, extracting enough energy from gunpowder gases to operate the mechanism without compromising accuracy or reliability. Japanese metallurgists analyzed every component down to the molecular level. They discovered the Americans used specific steel alloys hardened through precise heat treatment. The gas cylinder required steel that could withstand repeated pressure cycles without metal fatigue. The bolt components needed hardness ratings that resisted wear while maintaining smooth operation. Most critically, the tolerances were extraordinarily tight. Components machined to thousandths of an inch to ensure perfect gas sealing and smooth cycling. What the Japanese engineers couldn't replicate was the industrial infrastructure that made the M1 Garand possible. American factories possessed precision machinery that could hold tolerances impossible to achieve with Japanese equipment. The Springfield Armory and Winchester plants used assembly line production with interchangeable parts, manufactured to exacting standards. Each M1 Garand contained components that would fit any other M1 Garand, a manufacturing achievement that Japanese industry couldn't match. By 1943, Japan's strategic materials shortage was crippling weapons production. The steel alloys required for the Type 4's gas system needed chromium, nickel, and other metals Japan could no longer import. Substitutions using available materials weakened critical components. The precision machinery necessary for tight tolerances was being diverted to aircraft and naval production. Each Type 4 rifle required individual hand-fitting by skilled craftsmen, making mass production impossible. The first Type 4 prototypes completed testing in March 1943 with mixed results. In controlled conditions at the Kokura Arsenal's indoor range, the rifles functioned adequately. Engineers had successfully copied the M1 Garand's operating system, creating a weapon that could fire semi-automatically and reload via 8-round en-bloc clips. However, problems emerged immediately when testing moved to field conditions. The gas system, manufactured with inferior steel alloys, couldn't withstand the pressure cycles generated by Japanese ammunition. Bolts jammed when fouled with dirt or moisture. The feeding mechanism, crafted with looser tolerances than American standards, failed to cycle reliably. Most critically, the rifle's weight at 4.4 kilograms, nearly a full kilogram heavier than the Type 99, made it unwieldy for Japanese soldiers, averaging 20 kilograms lighter than American troops. Lieutenant General Yoshijiro Umezu, Chief of the Army General Staff, visited Kokura Arsenal in June 1943 to observe Type 4 testing personally. The demonstration began promisingly, with skilled technicians firing the rifles under ideal conditions. Then came the field simulation. Rifles were exposed to humidity, dust, and temperature variations that mimicked Pacific theater conditions. The results were catastrophic. Of 12 rifles tested, 9 experienced stoppages within the first magazine. 4 seized completely, requiring complete disassembly to clear. The metallurgy problems became apparent when several gas cylinders cracked under pressure, sending metal fragments toward the operator's face. Umezu's reaction was recorded by his aide-de-camp. "We have created a weapon more dangerous to our soldiers than to the enemy. This is not a rifle, but a sophisticated malfunction." The engineering challenges that doomed the Type 4 rifle revealed the vast gap between Japanese and American industrial capabilities. The M1 Garand's gas system operated at precise pressure levels that required specific ammunition characteristics. American .30-06 cartridges were manufactured to exacting standards with consistent powder charges and bullet weights. Each round generated precisely the gas pressure needed to cycle the rifle's action without excessive wear or insufficient power. Japanese ammunition production, hampered by materials shortages and quality control problems, couldn't match American consistency. Powder charges varied significantly between cartridges, causing cycling problems. Some rounds generated insufficient gas pressure to operate the action, requiring manual bolt operation. Others produced excess pressure that accelerated wear and caused violent extraction that damaged cases and chambers. Major Hiroshi Tanaka, the project's chief engineer, documented the ammunition problems in his technical report from August 1943. The Type 4 rifle functions perfectly with captured American ammunition, but fails consistently with our own cartridges. American ammunition demonstrates uniform performance across thousands of rounds. Our ammunition varies so significantly that each cartridge must be considered individually. We cannot build a reliable semi-automatic rifle around unreliable ammunition. The report recommended either improving Japanese ammunition production to American standards or abandoning the semi-automatic rifle project entirely. Both options were impossible, given Japan's deteriorating industrial situation. By September 1943, the strategic situation had shifted dramatically against Japan. The Guadalcanal campaign had demonstrated American material superiority in every category. Japanese forces faced enemies equipped not just with M1 Garands, but with submachine guns, automatic rifles, and crew-served weapons that rendered individual rifle superiority meaningless. The Type 4 project continued, but its military relevance was evaporating as American forces gained overwhelming firepower advantages through superior logistics and industrial production. Field Marshal Hisaichi Terauchi, commanding Southern Army, summarized the changing tactical situation in his October 1943 assessment. Individual weapons, however superior, cannot overcome enemy advantages in artillery, air support, and logistics. We are fighting the last war while the Americans fight the next one. The most damning evidence of the Type 4's failure came from its intended users. In December 1943, a limited number of rifles reached the 1st Infantry Regiment for combat evaluation in New Guinea. The results exceeded the worst fears of Japanese engineers. Private Takeshi Yamamoto's diary, recovered after his death at Buna, provided devastating testimony. The new rifle jams constantly in this heat and humidity. The bolt sticks when wet, which is always. We tried to clean it, but the parts are too complicated and break easily. My old Type 99 never failed me. This weapon will kill us faster than the Americans. The diary entries continued for 3 weeks, documenting increasing frustration with the Type 4's reliability problems before ending abruptly when Yamamoto was killed in action. Sergeant Major Kenji Suzuki, a veteran of the China campaign testing the Type 4 in Burma, filed an even more damaging report through military channels. The rifle is impossible to maintain under field conditions. Disassembly requires tools we don't have. Cleaning is complex and time-consuming. When parts break, which is often, the weapon becomes useless. American weapons we capture are simple, reliable, and easy to maintain. Our copy is none of these things. Suzuki's report concluded with a recommendation that shocked the General Staff. Issue captured American weapons to our best soldiers. They are superior to anything we produce. The industrial requirements for mass-producing the Type 4 revealed Japan's manufacturing limitations. Each rifle required 47 precisely machined components compared to the Type 99's 23 parts. The gas cylinder alone needed 5 separate machining operations on equipment Japan could barely spare from aircraft production. Assembly time was nearly triple that of conventional bolt-action rifles, requiring skilled workers whose expertise was desperately needed elsewhere. Most critically, quality control failures increased exponentially with complexity. While Type 99 rifles had a rejection rate of approximately 3%, Type 4 rifles failed initial inspection at rates approaching 30%. Rejected rifles required complete rebuilding, further straining production capacity. Colonel Yamada's monthly production reports painted a picture of industrial paralysis. January 1944, 47 rifles completed, 23 rejected. February, 38 completed, 19 rejected. March, 29 completed, 31 rejected. By April 1944, more Type 4 rifles were being rejected than accepted, while materials and labor could have produced over 200 Type 99 rifles instead. The mathematics of industrial efficiency demanded abandoning the project, but national pride and sunk costs kept production limping forward. The Type 4's mechanical complexity created maintenance nightmares that Japanese military doctrine couldn't accommodate. American forces possessed detailed technical manuals, spare parts supplies, and trained armorers at company level. Japanese infantry units had none of these advantages. Field maintenance doctrine assumed simple, robust weapons that soldiers could repair with basic tools. The Type 4 required specialized knowledge and precision instruments unavailable in jungle conditions. When rifles malfunctioned, which was frequent, they became useless dead weight that soldiers often abandoned. Captured documents revealed that Japanese units issued Type 4 rifles often carried additional Type 99 rifles as backup weapons, defeating the purpose of the semi-automatic system entirely. The ammunition situation deteriorated throughout 1944 as Japan's industrial base crumbled under sustained bombing. The Type 4 required approximately 30% more ammunition than bolt-action rifles to achieve equivalent effectiveness, straining supply lines already stretched beyond capacity. Japanese logisticians calculated that equipping a division with Type 4 rifles would increase ammunition requirements by 150 tons monthly. Transportation impossible given shipping losses and fuel shortages. Paradoxically, the weapon designed to increase Japanese firepower actually reduced it by consuming irreplaceable resources while delivering inferior performance. Captain James Morrison of U.S. Army Intelligence, examining captured Type 4 rifles in early 1945, provided the American perspective on Japanese reverse engineering efforts. The Japanese clearly understood the M1 Garand's operating principles and attempted faithful reproduction. However, their materials, science and manufacturing capabilities were insufficient for reliable execution. The rifle represents competent engineering hampered by industrial limitations. Morrison's technical analysis identified specific failure points: gas cylinder metallurgy that couldn't withstand pressure cycling, bolt components that wore rapidly due to improper heat treatment, and feeding mechanisms manufactured to tolerances too loose for reliable function. The Type 4's failure in tropical conditions revealed fundamental misunderstandings about American weapon design philosophy. M1 Garand engineers had extensively tested their rifle in various climates, developing specifications that ensured function in extreme heat, humidity, and dust. The rifle's components were designed with thermal expansion coefficients that maintained proper clearances across temperature ranges. Japanese engineers, working from captured samples tested only in temperate conditions, failed to understand these critical design requirements. When Type 4 rifles encountered Pacific theater heat and humidity, metal expansion caused jamming, corrosion accelerated wear, and moisture penetration caused internal fouling that Japanese maintenance procedures couldn't address. Lieutenant Yoshio Kodama, assigned to evaluate Type 4 performance with the 14th Army in the Philippines, documented the weapon's catastrophic failure under combat conditions. During the engagement at Bataan, 40% of Type 4 rifles malfunctioned within the first hour of combat. Soldiers were forced to use the rifles as clubs or retrieve enemy weapons from fallen Americans. The complexity that was supposed to give us advantage became our greatest vulnerability. Kodama's report noted that American M1 Garands, captured on the same battlefield, continued functioning despite similar environmental conditions, highlighting the superior engineering of the original design. The psychological impact on Japanese soldiers was devastating. Men who had trained with reliable Type 99 rifles lost confidence in their equipment and, by extension, their leadership's competence. Morale reports from units equipped with Type 4 rifles showed significant deterioration. Soldiers complained that their weapons were inferior to captured American equipment, undermining the narrative of Japanese technical superiority. Some units refused Type 4 rifles entirely, preferring to fight with older but reliable weapons. The rifle that was supposed to demonstrate Japanese technological advancement instead became a symbol of industrial inadequacy and strategic desperation. By August 1944, the month Colonel Yamada witnessed the testing facility failures, Japanese ammunition shortages had made the Type 4's problems irrelevant. Units equipped with semi-automatic rifles couldn't obtain sufficient ammunition to exploit their higher rate of fire. The complex logistics of semi-automatic warfare, requiring 3 times the ammunition, spare parts, and maintenance support, were impossible given Japan's collapsing industrial and transportation infrastructure. The weapon designed for offensive operations became useless as Japanese forces adopted defensive strategies that emphasized conservation of ammunition and resources. The final irony emerged in September 1944, when captured documents revealed American awareness of Japanese reverse engineering efforts. U.S. Army intelligence had monitored the Type 4 project through signals intercepts and prisoner interrogations. Colonel William Harrison, Chief of Enemy Equipment Analysis, noted in his intelligence summary, "Japanese attempts to copy the M1 Garand demonstrate both their recognition of our weapons' superiority and their inability to replicate it effectively. Their industrial base cannot support the precision manufacturing required for reliable semi-automatic rifles." The Americans understood Japanese capabilities better than Japanese leadership did. Production of the Type 4 rifle officially ended in November 1944, after approximately 250 rifles had been manufactured. Of these, fewer than 100 reached combat units, and survival rates were appalling. Post-war surveys identified only 18 Type 4 rifles in Japanese military inventories at surrender, suggesting that over 90% had been abandoned, destroyed, or lost due to mechanical failure. The project consumed resources equivalent to 2,000 Type 99 rifles while delivering negligible combat effectiveness. It represented one of the war's most complete failures of reverse engineering and industrial conversion. The Type 4's failure highlighted fundamental differences between Japanese and American approaches to weapons development. American design philosophy emphasized simplicity, reliability, and mass production. The M1 Garand succeeded because it was engineered for manufacture by semi-skilled workers using mass production techniques. Every component was designed for interchangeability and easy replacement. Japanese weapons tradition emphasized craftsmanship, precision, and individual excellence. This approach produced superb weapons in small quantities, but couldn't scale to industrial requirements. The Type 4 project failed because Japanese engineers tried to apply artisanal methods to mass production requirements. Intelligence assessments after the war revealed that Japanese leadership understood the Type 4's problems, but continued production for morale purposes. General Hideki Tojo's staff knew by mid-1943 that the rifle would never achieve military effectiveness, but cancelling the project would have admitted Japanese technological inferiority. The psychological investment in proving Japanese engineering could match American achievements overrode practical military considerations. National pride transformed a failed weapons project into a strategic liability that diverted scarce resources from more promising alternatives. The contrast with American weapons development was stark. While Japan struggled to produce 250 unreliable Type 4 rifles, American factories manufactured over 5.4 million M1 Garands with consistent quality and reliability. Springfield Armory alone produced more M1 Garands in a single month than Japan managed Type 4 rifles during the entire war. This disparity reflected not just industrial capacity, but fundamentally different approaches to engineering and manufacturing. American success came from systematic engineering, rigorous testing, and industrial processes designed for mass production. Japanese failure resulted from attempting to replicate American achievements without understanding their industrial foundations. The Type 4 rifle's legacy extended beyond its military ineffectiveness to influence post-war Japanese defense thinking. Veterans who had experienced the weapons failures became advocates for foreign military assistance and technology transfer rather than indigenous development. The rifle's problems demonstrated that copying superior foreign weapons without understanding their industrial requirements was futile. This lesson influenced Japan's post-war defense industry, which emphasized licensed production and technology partnerships rather than independent reverse engineering. Technical analysis of surviving Type 4 rifles confirmed the specific engineering failures that doomed the project. Metallurgical testing revealed that gas cylinders used steel with approximately 40% lower fatigue resistance than M1 Garand components. Tolerance measurements showed variations 5 times greater than American standards, preventing reliable interchangeability. Heat treatment analysis demonstrated improper tempering that left components either too brittle or too soft for reliable function. These technical deficiencies were symptoms of broader industrial inadequacies that no amount of engineering effort could overcome. The human cost of the Type 4's failure was measured in soldiers who died because their weapons malfunctioned at critical moments. While precise casualty figures attributed to rifle failures are impossible to calculate, diary entries and after-action reports document numerous instances where Type 4 malfunctions resulted in Japanese deaths or mission failures. Private Hiroshi Tanaka's final diary entry from Iwo Jima mentioned his Type 4 jamming during the American assault. "My rifle failed when they came over the ridge. I tried to clear it, but there was no time. This weapon has killed more of us than the enemy." Tanaka was found dead beside his jammed rifle, its bolt seized in the extended position. American forces occasionally captured functional Type 4 rifles and subjected them to technical evaluation. Lieutenant Colonel Robert Bruce, commanding the Pacific Technical Intelligence Center, summarized American assessments. The Type 4 represents competent reverse engineering undermined by industrial limitations. Japanese engineers understood the M1 Garand's principles, but lacked the manufacturing capabilities to execute them reliably. The result is a weapon that demonstrates Japanese technical ambition exceeded their production capacity. Bruce's report noted that captured Type 4 rifles often functioned adequately when maintained by American armorers with proper tools and spare parts, highlighting the importance of logistical support for complex weapons systems. The strategic implications of the Type 4's failure extended beyond individual weapon effectiveness to illuminate Japan's fundamental disadvantages in industrial warfare. The project's collapse demonstrated that technological superiority required not just engineering competence, but comprehensive industrial infrastructure. Japan possessed excellent engineers, metallurgists, and craftsmen, but lacked the systematic manufacturing capabilities that made American mass production possible. This industrial gap proved decisive across all categories of military equipment, from aircraft to ships to small arms. The Type 4 rifle project became a case study in the futility of attempting to match enemy capabilities without addressing underlying industrial weaknesses. Japanese leadership recognized American weapons superiority, but failed to understand its foundations in mass production, quality control, and logistical support. The attempt to copy the M1 Garand without replicating American industrial methods was doomed from the start. The project diverted resources from more appropriate weapons development, while failing to deliver meaningful military capability. Colonel Yamada's final report on the Type 4 project, submitted in December 1944, acknowledged complete failure. "We have attempted to create American weapons using Japanese methods and materials. The result satisfies neither American standards nor Japanese requirements. Our soldiers deserve reliable weapons they can maintain and trust. The Type 4 provides neither reliability nor simplicity. We recommend immediate termination and return to proven designs." Yamada's recommendation was accepted, officially ending one of the war's most expensive failures in weapons development. The post-war fate of remaining Type 4 rifles illustrated their military uselessness. Most were scrapped immediately after surrender, deemed unworthy of preservation even as museum pieces. The few examples that survived were retained primarily as curiosities rather than functional weapons. American ordnance experts who examined Type 4 rifles after the war expressed surprise that Japanese engineers had attempted mass production with such inadequate industrial capabilities. The consensus was that Japan would have been better served improving existing weapons rather than attempting to copy American designs. The Type 4 rifle stands as a monument to the dangers of technological overreach during wartime. Japan's attempt to rush a copy of America's premier infantry weapon failed catastrophically, consuming precious resources while delivering a weapon that jammed in jungle heat and failed when soldiers needed it most. The project's collapse demonstrated that in industrial warfare, the ability to manufacture weapons reliably matters more than the brilliance of their design. Japanese engineers understood this too late, after scarce materials and skilled labor had been wasted on a weapon that symbolized everything wrong with Japan's approach to technological competition. The ripple effects of the Type 4's failure extended into Japanese military doctrine and training. Units that had been reorganized around semi-automatic fire tactics found themselves reverting to bolt-action methods mid-campaign. The 32nd Infantry Regiment, equipped with Type 4 rifles for the defense of Luzon, abandoned their semi-automatic weapons after the first week of combat. Major Kenji Nakamura reported, "We trained our men for rapid-fire assault tactics. When their rifles failed, they had forgotten how to fight effectively with bolt-action weapons. We lost tactical advantage twice, first to unreliable equipment, then to inadequate training for backup scenarios." The psychological warfare implications were devastating for Japanese forces. Word spread through military channels that American weapons were superior to Japanese copies, undermining confidence in domestic production across all categories. Sergeant Taro Ishida, captured on Saipan with a jammed Type 4, told interrogators, "When our best engineers cannot copy enemy weapons successfully, what hope do we have of matching their tanks, planes, or ships? The Type 4 taught us we were already defeated." This defeatism, spreading from individual weapon failures to broader strategic pessimism, accelerated the collapse of Japanese military morale in the war's final stages. Intelligence intercepts revealed that Japanese high command recognized the Type 4's propaganda value to enemy forces. General Korechika Anami's staff warned that captured Type 4 rifles were being displayed by American forces as evidence of Japanese technological desperation. The weapon designed to demonstrate Japanese engineering prowess instead became proof of industrial inadequacy. American psychological warfare units distributed photographs of jammed Type 4 rifles to Japanese positions, accompanied by surrender leaflets asking, "If your leaders cannot make reliable rifles, how can they win this war?" The medical implications of Type 4 failures created additional burden on Japanese forces. Field hospitals treated soldiers injured by exploding gas cylinders, bolt mechanisms that shattered under pressure, and metal fragments from catastrophic failures. Dr. Hiroshi Yamamoto, treating Type 4-related injuries at a field hospital in Burma, documented 12 cases of facial lacerations from gas cylinder explosions in a single month. "The weapon wounds our soldiers more effectively than enemy fire," he wrote. "We are literally fighting ourselves." Post-war examination of captured Japanese documents revealed the extent of cover-up efforts surrounding Type 4 failures. Reports of weapon malfunctions were classified as military secrets to prevent damage to morale and leadership credibility. Colonel Yamada's honest assessments were suppressed, while fabricated success stories were circulated through military publications. This institutional dishonesty prevented necessary corrections and resource reallocation, compounding the project's negative impact. The culture of face-saving that enabled the Type 4's continuation, despite obvious failure, reflected broader problems in Japanese military decision-making that contributed to strategic defeat. The economic cost of the Type 4 project extended beyond direct manufacturing expenses to include opportunity costs and resource misallocation. The steel, aluminum, and skilled labor devoted to Type 4 production could have manufactured 2,000 additional Type 99 rifles or critical aircraft components. Japanese war planners calculated that Type 4 resources could have produced 50 additional fighter aircraft or naval equipment equivalent to 2 destroyers. These alternative uses would have provided genuine military capability rather than the illusion of technological advancement that the Type 4 represented. The lasting lesson of the Type 4 rifle extends beyond its specific technical failures to broader questions of industrial strategy and technological development. Japan's attempt to copy American success without understanding its foundations was doomed from the start. The project consumed resources that could have improved existing weapons or developed alternatives better suited to Japanese capabilities. Instead, national pride and technological ambition combined to create a weapon that failed its users at the moment of greatest need. The Type 4 rifle jammed in jungle heat because Japan had attempted to build American dreams with Japanese reality, creating a nightmare that haunted soldiers until the war's end.